Okay, we talked about polygons. Polygons, remember, have no curves in them, all straight lines. They are closed and no sides intersect. So there are different types of polygons. We've already done the triangles. Triangles just means it has three sides. Triangles are split into different types of triangles: acute, obtuse, right, scalene, isosceles, and equilateral. So we've already done all the triangles, so now what we're doing is quadrilaterals.
So there's like in the different branches that we do?
Yeah. So every quadrilateral is a polygon, but is every polygon a quadrilateral? No, because it could be other types. So quadrilaterals are split into different types. If you saw a picture like this, it's just a plain old quadrilateral. It has no special name to it. But quadrilaterals can be split into, there are squares, rhombuses, oops. Oh, wait a second, I should do this first. Parallelograms, we just did. Okay? And parallelograms, there are different types of parallelograms. Could a square be considered a parallelogram?
Yeah.
Yeah. Could a rhombus be a?
Yeah.
Yep. And a rectangle is also a parallelogram. So, rhombuses are parallelograms every time, but are parallelograms always a rhombus? No, it can be different. Okay? So when you work up this way, some of the assignments that we have is they'll give you a picture. I'll just give you a picture of a square. And you've got to name every possible thing this could be called. Obviously, the most specific name would be a square. But it is also a parallelogram. So remember,
And a quadrilateral and a polygon?
Couldn't it be a rhombus?
Because if you look at it like this.
I'll get to that in a second when we do these three, you'll see. But you can work your way up backwards this way. A square is a parallelogram, and it is also a quadrilateral, and it is also a polygon. Okay? So, of these three things, that's what we're doing today: squares, rectangles, and rhombuses. In a square, it's easier just to draw the picture to show you what's true on all of this. I think everyone knows, or I hope everyone knows, a square has 4 90s. All sides are equal, right? So obviously parallelograms work because consecutive angles are supplementary, opposite angles are equal. Now the other thing that people don't know quite as often is this. Since it's a parallelogram, what do you know about diagonals?
They're perpendicular. No, I don't remember the word.
What happens to the diagonals in a parallelogram?
They cross.
They cross.
Bisect.
They bisect each other. So in a square, this will equal that, and this will equal that, and they'll all equal each other. So what it makes is 4 isosceles triangles. Now what is also true in a square is when they meet, they are perpendicular. So what you can do is you can use the Pythagorean theorem because you got 4 right triangles. Okay? Now since it's a diagonal and this is a 90 on a square, do you know what each of these will be?
180.
45, 45, right? 45, 45, 45, 45, 45, 45. Okay? So, in a square, the added thing that people don't really realize is on top of the diagonals bisecting, the diagonals bisect each other. And are perpendicular. Okay, so that's the one thing you gotta remember on that people don't really deal with much. On a rectangle, again, the only difference is all the sides are not, well, it's not the only difference, but it's just opposite sides are congruent, like that. All four sides are 90, so it is a parallelogram, which means since it's a parallelogram, the diagonals do bisect each other. And how do you suppose they compare to each other, all four parts of the diagonals?
They're equal.
They're all equal too. Just like in here. So the diagonals bisect each other in a rectangle, but do you think they're going to be perpendicular?
No.
No. Diagonals are not perpendicular. And then on a rhombus is like a square that's been tipped. It's like a diamond. All four sides are equal and parallel. So they would have the little triangles on there. Okay, but they're not necessarily 90. Opposite angles are congruent. Consecutive angles add up to 180, are supplementary. The diagonals, again, do bisect each other. But they're not all going to be the same length like in these two. Obviously, this is shorter than that, right? Now, if I drew this better, this would be, they are perpendicular in a rhombus. Okay? So those are the things about a rhombus. So, if you had a rhombus, forgetting about the picture, all the things are true is all four sides are equal, opposite angles are equal, diagonals bisect each other, diagonals are perpendicular. Could you call it a square?
Yeah.
Sometimes, right? That's sometimes, always, never stuff. Sometimes it could be, the only time would be is if they're all 90. But if you had a square, could I call a square a rhombus?
No.
So a rhombus just has to have opposite angles equal. It has to have all four sides equal. It has to have diagonals that bisect each other, and the diagonals have to be perpendicular. If it's a square, could it be called a rhombus? Yes. Everything true in a rhombus is true in this square. But everything true, if you have a rhombus, it's not always going to be a square, only if these were 90. But if you saw this picture, a rhombus has to have all four sides equal, which it does. It has to have opposite angles equal, which it does. It has to have diagonals bisecting each other, which it does. And they have to be 90, which it does.
So a square can always be a rhombus, but
Yep.
a rhombus can't always be a square.
Right. A square is always a rhombus, but a rhombus is sometimes a square. Then a rectangle, if I had this one, could you call it a square?
No.
No, sometimes if all four sides were equal. But if you had a square, could you call it a rectangle?
No. Yep.
Yeah.
Yes, because everything true here is true in this.
Except diagonals are not perpendicular.
Well, if you have a square, now think of the things of a rectangle. Our opposite side, if you have this picture, in order for it to be a rectangle, are opposite sides equal? Yes. Are all four corners 90? Yes. Do the diagonals bisect each other? Yes. So that's why everything true of a rectangle is true in a square. So a square is the one that could be called everything. It could be called a rhombus, a rectangle, a parallelogram. I'll just list it down here. It could be called a quadrilateral, it could be called a polygon. So 6 things you could call it, but obviously what's the most specific name? Square. So a rectangle can't always be called a square. Sometimes it can, but not always. So a rectangle, if you named all its names, it would be a rectangle, a parallelogram, a quadrilateral, or a polygon. Same thing with a rhombus. Rhombus is most specific, but you can also call it a parallelogram, a quadrilateral, and a polygon. So here we got the sometimes, always, never. A square is sometimes, always, never a rectangle.
Always.
Always.
Never.
Next one's never.
Sometimes.
A rectangle is a square sometimes, if all the sides are the same. That one, these questions I always thought are stupid because if all the sides were the same, you'd just call it a square, not a rectangle, right? But
So the square and rhombus thing, so if there was a question of what is this, is it square, rectangle, or rhombus? If it's a square, we can put rhombus for it.
you could, unless it asked for its most specific name.
Yeah.
But otherwise you could, yep. Okay, ABCD is a rhombus. What else do you know? It has 4 congruent sides. Opposite sides are congruent and parallel, right? Opposite angles are congruent. Its diagonals bisect. And
L bisect and
Congruent, parallel.
perpendicular. They form a 90. And the consecutive angles are supplementary. Remember, consecutive are any 2 in a row. All right. So here we're just finding, it's really nothing different. Find the value of y. Since this is a rectangle, how many degrees is that? 90. So 7y plus 6 has to equal 90. Then you just got to solve it. Divide by 7 and you get 12. Really not very difficult problems. So, sometimes, always, never. Is a rhombus sometimes a square, always a square? A rhombus is sometimes, if all the angles are 90. A parallelogram is sometimes, always, never a rectangle. Sometimes. A parallelogram is sometimes a rectangle. Because it could be just a plain old parallelogram. You know?
If it was switched around, it'd be always, right?
A rectangle is always a parallelogram, yep. And on these, since this is a square, what would you do to figure out what x is?
that equals that.
That equals that. 13 minus 6x has to equal x plus 27. So I would move the 6x over since it's a minus, change it to positive. So get the non-x's to the other side, it's a plus, so subtract. Divide by 7, and you get negative 2 for x. Okay, so here's something, you guys probably know this. If you were building something and you wanted to make sure it's square, has anyone ever built like a wall and then you gotta make sure it's square? No? Do you know what you do to make sure something is square when you build it?
Use a level. You do that little bubble thing, you use a level.
No. No?
Or an angle iron.
What did you say, Amelia? You gotta measure the diagonals. If something is square, the distance from here to here has to equal there to there. Okay, so that's all you check to see if something's square. So, what you've got here is 8 and 8. This makes a right triangle. So what would you do to figure out what this should be? Right. What kind of figure is this? Right triangle. Shh. Quiet. If you know two sides of a right triangle, you can find the third by using the Pythagorean theorem. It's 8 squared, 8 squared. Do you add them or subtract them? Add. When you're looking for the hypotenuse, you add them. So 8 squared plus 8 squared, and then remember you got to square root it. And it should turn out to be 11.31 inches or whatever, or feet. So when you measure it, you should get 11.31 and 11.31 if it's square. Now, do you know how to change 0.31 into inches? It would be 11 feet. Not divide by 12. Times it by 12?
No, just kidding. Do it square.
When you're building something, what's probably the smallest unit of measure that you go to? No.
Meters, millimeters.
We're in feet right now.
Inch. No.
Now you cut things less than an inch. What's the smallest amount? 16ths.
I said that.
Right?
I said that.
So if you take 0.31 times 16, that's 4.96, which you could round to 5. So it's pretty close to 5/16 of an inch. Anytime you're making a decimal into feet and inches, you just take the decimal times 16 if you want 16ths. What if you wanted it in eighths? Multiply by 8. Okay, true or false? Are the diagonals of a rhombus always congruent? That means, are they the same length, the diagonals? No, you can see this one is always going to be shorter than that one. So that's false. Are the diagonals of a square never perpendicular? False, they're always perpendicular. Each diagonal of a rectangle sometimes bisects a pair. Now this is the key right here. In a rectangle, is that going to bisect this angle? No, this is smaller than that, right? But it doesn't say always bisect, it says sometimes bisect.
If it was a square, it could.
If it was a square, if all the sides were the same, so that would be true. That's a tricky one. Now, if it's an actual rectangle, they would never bisect it. But remember, rectangles are sometimes squares. Okay. Okay, I'll do the first couple with you, although the answers I already got on the board for you, just gotta find them.
David.
I just think I'm gonna pass off. Sid, what? Is this app automatically saying you? Connor, wait, or do you want? Connor. Connor, you ever seen Mint? Like, oh, that's so weird. Mint. That's a fast no say. No, it's like, that's the new like word for
Connor started it over here.
That's so mint. It's not cool.
I get it. Let me try. Grab it and mix it up. So I can say it's all. Don't mix it up.
So, these first ones, 16 through 21, you need to list each one of these which is true. So you don't need to go through the work of saying it's a quadrilateral and a parallelogram every time. You just gotta say, could you call it a parallelogram, rectangle, rhombus, or square? So, if it's equiangular, that means equal angles. If all the angles are equal, could it be a parallelogram?
No.
Remember, parallelogram just means opposite angles are equal. So if they're all equal, are opposite angles equal?
That's a rectangle and a square.
Listen. If something's equiangular, that means they're all the same. Which means they have to be what?
Perpendicular.
What do they have to be if they're all the same?
Congruent.
Square.
Or rectangle.
What does each angle have to be if they're all the same? 90. Okay. In order for it to be a parallelogram, opposite angles have to be congruent. Are opposite angles congruent? Yes. So you could call this a parallelogram. So you can just put the symbol instead of writing a word if you want.
For number 61.
So, could you call it a rectangle?
Oh.
Yes. Could you call it a rhombus?
Can you not?
Do we have to do all of them?
Yes.
Do we have to write
Yes,
all
you
of them?
could.
Or just one?
Because the rhombus could be a square.
Like for each one of these, do we have to write every one that works?
But see, it could be.
No, because it's
No,
not.
it's not.
18, would
No.
they all
A
be?
rhombus could be.
Yours over there, Jared.
Yeah. We.
No.
Or all of them except for the parallelogram?
Wouldn't a square be one too?
Yep.
Yeah.
Not the rhombus
Somewhere it
though.
is.
Okay, the link.
Rhombus
Rhombus isn't, is
and
it?
a square. Remember, a rhombus could have all 90s.
So it's could,
It could.
not always.
So list each quadrilateral for which the statement is true. It could be true.
The diagonals, does that mean?
Oh, I see. Oh.
Well, you know what, to make this easier,
Just list one.
let's just go by what they have labeled here then.
Okay.
So then
So let's
rhombus
look at the
would-
picture, what they got labeled, then we don't have to list as much stuff. So, of these up here, which ones are equiangular?
Squares.
Square and a rectangle.
Square, you can just put SQ, rectangle, you can just put RECT. Okay. 17, equiangular and equilateral, square. Of these, which ones have diagonals that are perpendicular? There you gotta look up on the wall, or on the board.
Square. Rhombus and a square.
Rhombus and a square. Okay, so you can finish those.